Yo, what's up? This is Dr. Schleif with another physics question, and this is a ballistic pendulum question, as you can see on the screen. A wooden block freely supported on brackets at a height of 4 meters above the ground, as shown. We're going to fire a bullet whose mass is 5 grams, moving 200 meters per second into that wooden block, and we want to calculate the height of the block above the ground. All right. Don't forget to add back in these 4 meters once you've calculated how high up above this bracket, the wooden block, bullet combined system will go. Let's jump over to the chalkboard. Momentum is going to be conserved, right? So we have the initial momentum equal to the final momentum. All the initial momentum is going to come from the bullet. Since everything is in grams, maybe we're okay to just stay in grams. You as a student of physics might be in a habit of converting grams to kilograms, right? If we have to get newtons of force, then we need kilogram meters per second squared. And so sometimes it's helpful to just sort of always go to kilograms. But we'll just kind of calculate the momentum in gram meters per second, okay? So what's 200 times 5? 1,000 gram meters per second of initial momentum. So afterwards, we're going to have that much momentum. We've got this new object whose mass is 100 grams. And so how fast does that object need to be moving in order to preserve the linear momentum? So 100 times what number is 1,000? 10, right? So this thing's got to be going at 10 meters per second. So we know that sort of the afterward velocity is 10 meters per second. If you launch something up into the air with a velocity of 10 meters per second, how high up will it go? We could think about that as, well, 10 meters per second of velocity is going to have kinetic energy. So we could say this new object, this bullet block object, is going to have kinetic energy. That's going to all be converted into potential energy. Okay, so whatever kinetic energy it possesses upon impact, we're going to convert all of it into potential energy. So we could say that the 1/2 mv squared of kinetic energy becomes mgh of potential energy, and the mass will cancel. And we could calculate the height here as let's see, v squared over 2, so like the 1/2, and then we got to dividing set by 2. So v squared over 2t. M squared over 2. Take care there if you don't, want to there to walk around. Have a good rest of your day, everybody. We're gonna keep good physics calculation going here. So, by about 20, what's 2 times 9.81? .62. So we'll go 100 divided by 19.62 gives us a height of 5.1 meters. So remember we said you don't want to be so satisfied with your answer here that you choose that answer incorrectly. Add back in the 4 meters of initial height to get a final answer of 9.1. So 9.1 meters is what we would report as our final answer to this. This has been another worked example with Dr. Schleif, still living a physics life. See you next time.